I work for a small organization here out of Jensen Beach called Inwater Research Group. We're a bunch of biologists and educators that primarily do sea turtle conservation. Our big thing, our bread and butter, is studying sea turtles in the water. Historically in Florida, there were large populations of sea turtles, especially green turtles. And they were targeted by fisheries that were looking to catch sea turtles. This is what they used to make sea turtle soup out of and turtle steaks. And is what they would do is they'd catch the turtles here in the Inwater Lagoon or near shore using nets. They'd hold them in pens and then they'd ship them up to New York alive typically, and they would go ahead and harvest them there. Have any of you been to the Turtle Crawls bar in Key West? Okay, so that is where the pens used to be in Key West. Right there off of, like if you're looking out the bar, that's where they were right there. There's a little museum. If you ever get down there, check it out. It's really cool. And at that point, so by the 1900s, they had already fished out sea turtles in the state of Florida. Way before the Endangered Species Act, they went ahead and they started catching turtles off of Nicaragua. So they were actually Canadian fishermen that would go to Nicaragua, and then they would bring those turtles back to Key West. That was the last fishery in the United States. They put themselves out of business by the 1960s, late or early 70s, because they couldn't do it anymore. There were no more turtles for them to catch and make it fiscally worthwhile to do. So before the Endangered Species Act, basically green turtles were almost extinct or functionally extinct in the state of Florida. But we've seen this incredible thing through conservation practices. In the late 1980s, there was maybe somewhere between 5, 10, and maybe 100 or 200 nests per year. And we're seeing this exponential increase in green turtle nesting in the state of Florida. And a lot of the information that we've learned about sea turtles is through the nesting beach process, right? It's really easy to find a turtle on the beach. They're kind of slow crawling up the beach. They kind of hang out for a while they're digging. It gives researchers time to go ahead and measure the turtles, take samples, better understand the biology of the hatchlings on the beach. But once they leave the beach, that we don't have access to them as easily. They're spending 99.9% of their life, male turtles never come back to their nesting beaches, in the water. But that's the least studied portion of sea turtle behavior in biology because they're harder to catch in the water. It's more expensive. Now you need a boat. You have to go out and find them. You know, things dealing with boats are just obviously always more expensive than hanging out on the beach at night. So not as much research gets done on these turtles in water, but that's where they're spending most of their time, and that's kind of where we come into play. And one of our missions is to try to fill in some of those gaps about what's going on out in that ocean. And so we have study sites all over the southeast United States, most in Florida. We'll go through some of them today. Right here near the Inwater Lagoon on Hutchinson Island, down in Lake Worth Lagoon, near Peanut Island, the Keys. This is off of Crystal River, and then just off of Louisiana in the Gulf of Mexico. So the first one, and this is maybe the most local interest, is at the St. Lucie nuclear power plant. So that's where my day job is. I spend most of my hours. The St. Lucie nuclear power plant is owned and operated by Florida Power and Light, and there's 2 twin nuclear reactors there, and they pool their cooling water from the ocean. So it's a flow-through system. Water comes in here, comes in under the beach. Actually, I'll do it this way. Comes in under the beach. There's 3 pipes out there under the beach and comes into this giant intake canal. The pipes one is 16 foot in diameter, the other 2 are 12 feet in diameter. 16 feet's big enough to drive a school bus through. So they pull in 1 million gallons of seawater a minute, and it's all gravity fed. So this canal sits below sea level. The pipes are in the ocean. The water just comes downwards and flows in. There's no pumps until you get to the actual back of the plant proper. But we have set up a series of nets. The first one here is about 100, 150 yards from the beach, and that prevents anything bigger than 5 inches across from getting past that net. So all the big stuff stays here. Some of the small fish can get through, but then mostly after that, it's just the water. So our job as biologists every day is to get the big stuff out. And primarily the sea turtles. They're a threatened and endangered species. That's why we're paid to be there every day. And it's interesting, it's an industrial site. It's not what you normally think of when you think of sea turtle biology or rescuing turtles. So we have a couple of different methods of doing that. The first way is we set tangle nets. So these are kind of like just giant fishing nets. They don't have a lead line on the bottom, so they're not pulled to the bottom. And when the visibility is poor, the turtles don't see the nets, they run into them, they get tangled up, and they float to the surface. So there's nothing stopping them. They have a very difficult time drowning in a net. And we watch from our trailer on the side of the canal. And once we see the buoys move or do something odd, we go out in a boat and grab the turtle. When the visibility is good, which is just a handful of days per year, we're able to actually go in and free dive. The deepest part of the canal is about 25 feet deep. We'll free dive and actually pursue the turtles and hand capture them. Once we get the turtles, this is it's a standard set of measurements. We'll take lengths, widths, with soft tapes, with calipers. We'll tag the turtles. We'll put in flipper tags, little metal flipper tags like this that anybody could see if they come across the turtle. We'll also put a microchip in, like you'd put in your cat or your dog, so you need a little scanner for that. We do both methods. Sometimes we sample for blood, depending on the researchers we collaborate with. And then we'll release the turtles. So the green turtles, we release a little bit south down at Walton Rocks. There's some habitat that they like there. Loggerheads we send to the north. Hopefully they don't swim back in that day. We've had that happen before. We've caught the same turtle twice in a day. So this is one of my colleagues, Jeff, who's going to check out the grouper. And he always gets the easy captures, sleeping. And so he'll take a hold of the turtle and point it upwards, and hopefully it'll swim in the same direction Jeff wants to go. Doesn't always happen, but it definitely helps. That's kind of one of the easy ways we do it. The interesting thing, and gets lost a lot of times, is that we find a lot of turtles with injuries and abnormalities that most likely aren't from the power plant itself. These are some external tumors we'll talk about a little bit later. Shark bite on that flipper. This loggerhead has a boat strike, so it impacted the hull. Long line fishing hook. So these are all injuries and abnormalities that the turtles had. It wasn't something that happened because they got caught at the power plant. And the turtles were still swimming and active, and we were able to get them to a rehabilitation facility while they were still relatively healthy. A lot of times when we get stranded turtles, the way we find stranded turtles, like here at the Smithsonian, that turtle was so debilitated that it just washed in with the currents and the wind. And at that point, they're a little harder to save. These guys still have some fat stores, they still have a little kick in them, and the survivorship seems to be slightly higher. Another thing that's been really beneficial about this, we've been doing this project since 1976, tagged almost 17,000 sea turtles, is we can see where these turtles go. Our loggerheads are spread out from the Carolinas down mostly through Cuba. A lot of them are found here in the middle of the state nearby. What happens a lot of the time is we tag the turtle, and that turtle shows up on a nesting beach somewhere. Researchers see it there. Same with green turtles. Most of our turtles are found again on the east coast of Florida, but we do have a large number that end up in Nicaragua. And the reason we get tag returns from Nicaragua for both species is there still is an active sea turtle fishery down there, and they hunt them down off the Mosquito Keys, and those fishermen get paid a couple bucks to return the tags. So we know that our little turtles here at some point are making their way the whole way down to Nicaragua and getting captured down there. This is another interesting story. So we caught kind of just a typical loggerhead. It's our most common size. But when we flipped it over out of the net, it had something on its back. And we recognized pretty quickly that that was a satellite tag. And it wasn't working. We could see the antenna had been missing. So we pried it off the turtle's shell, and we sanded down the side of it to see if we could get a serial number. They strapped $5,000 to its back and let it go. And this turtle actually was tagged in the Mediterranean Ocean off of Spain. Yeah. So it was captured in the Mediterranean in 2012. That year in October, the tag stopped working. They didn't get a couple of months out of it. And we captured it in April of 2014. So in 565 days, it traveled a straight line distance of 4,430 miles. So this was the first that I had ever heard of a loggerhead coming from the Mediterranean and going to the east coast of the United States. There's supposed to be distinct populations. We know that obviously the oceans are connected, but it's kind of a small connection between the two there at the Straits. So we emailed emailed the person who does all the tagging for the entire North Atlantic and said, hey, have you ever heard of this before? And he comes back and he says, go check your database a little bit harder. We actually had another turtle that was flipper tagged that was caught in the Mediterranean. So the 2 live turtles that we've ever identified that come from the Mediterranean to the east coast of the United States were captured at the St. Lucie power plant. So there's some connectivity there, yes?
Is there like a current that would flow?
There is. So as the Gulf Stream goes this way, goes clockwise, there is another current, and the name I'm missing right now comes down the other way. It kind of makes a big clockwise circle. So there is a current they would catch to come across. But we know they can swim straight across too. The turtles, it's really interesting. Turtles that nest in Japan swim straight across the Pacific Ocean, almost straight line to forage off of Mexico. Another project we've been doing for a while, is down in Lake Worth Lagoon. So if you're familiar with that area, this is Riviera Beach. This is Peanut Island, Blue Heron Bridge here. So we're just to the north, right up here. And these seagrass beds kind of behind the condos. It's a very populated area, all the houses and buildings and condos and that sort of thing. And we've worked while setting nets. We also do dip nets. So basically we pursue the turtle, we see it in the water, we chase it kind of with the boat, and then we go ahead and dip net the turtle. So we've been working there since the early 2000s and looking at the species there. It's primarily green turtles. And one of the things we're seeing there is this disease called FIBROPAPILLOMATOSIS. We call it FP for short. It creates these cauliflower-like tumors. It can be varying colors. Basically, it's associated with a herpes virus, nothing that we can catch. It's a turtle herpes virus that seems to show up most prevalently in turtles that are in areas with polluted waters. The animals are more stressed. So they get these giant tumors. It doesn't necessarily kill the animal, but the tumors hinder their ability to forage, find food, escape predators. They take energy from the turtle from just doing other stuff and use that energy to build the tumor itself. So we see this primarily in waters that are, we think, degraded. Indian River Lagoon here, 50% of the green turtles have these tumors. If you go to the ocean side of the island, 2 to 3% have them. So it's just a water quality issue. There's probably not just one specific pollutant in the water that's causing it. It may be different things in different places. We are able to remove them, but it is a virus, so it doesn't get rid of the virus. And so there's some people starting to look at the disease from that point. They're looking at it more of like how you would treat cancer or other viral diseases in humans and trying to treat it that way. But it's super experimental at this point. So we do see the turtles, you can remove them. You remove the tumors with a laser, they cauterize it. And some of the turtles, they don't grow back, sometimes they do. So one of the issues is a lot of times the turtle strand, they're so sick and debilitated by the tumors, even the tumors are dying because the turtle doesn't have enough food to even feed the tumor. Then you take the turtle and put it in rehab and give it food and give it nutrients and give everything it needs, and then tumors start to grow back. Bigger. So then you do the surgery, but now the turtle's in better condition, but the virus is still present. So there hasn't been there's been a lot of talk and thoughts, and this has been going on for a while, and nobody has been able to come up with the silver bullet just yet. So again, this is associated with pollution and generally seen in areas where there's a lot more people. Another place we work is Key West. This is one of our first studies. I have to say this is one of the hardest and most grueling places to do field work in the world. Right off of Duval Street. It is absolutely horrible. There we have different habitats we're looking at. We have dense seagrass beds, sponge grounds, kind of a mix of both. This is actually an old jetty that is submerged. It was 100 years old. Look at these different habitats. Nobody had ever gone down to the Keys and looked to see how many sea turtles are there or what species and that sort of thing. So we started doing that. This kind of shows the way that we catch turtles down there. This is what we call the rodeo method. It'll become a little bit clearer here in a second. Basically, this is the safest and the most efficient way to catch turtles in clear waters. We don't have to worry about nets. We don't have to worry about catching bycatch like sharks or rays. So basically, we find the turtle, we pursue it with the boat till it tires out a little bit, then we just jump on it. It really, honestly, is the easiest way for us to catch turtles. We don't have to worry about scraping along the seagrass beds with our nets. We don't have to worry about catching rays and sharks or manatees and dolphins. We can catch the turtle that we want to catch at that specific time and bring it to the surface.
How does the turtle feel about
The turtle, they're not super happy about it. You know, I mean, think about it. We're just a giant shark to them at this point. You know, like there's something pursuing them from above and it won't stop. And they exhibit what we think of the same behaviors, as escape behaviors, as they would if it was an actual predator. However, we just got some results back recently from somebody who was taking stress samples, and we gave them samples of our turtles, looking at the blood and stress levels in our turtles that we captured this method versus turtles that had been hooked on fishing piers and wound in and then sent to rehabilitation facilities, and actually found that our turtles exhibited stress levels that were at or very close to the stress levels of what they consider like baseline, like as low as we could possibly get. So they're not getting super stressed out over the deal compared to as if they were going, the turtles that were spent time in a rehabilitation facility were significantly more stressed. So it's the least stressful way we've been able to do that. So we're excited about that.
Do you have to worry about getting bit?
Yes, absolutely. Loggerheads, particularly loggerheads, they have a big giant skull that's used for cracking conch shells. So an adult loggerhead can get through a queen conch shell, just bite it right in half and get the snail inside. So fingers, not a problem. Their defensive mechanism, they're not as fast as say a green turtle. Green turtles are really hydrodynamic. They keep their shells clean. They're really nimble and agile. Loggerheads aren't. They're kind of slow. They look like the reef moving across the bottom. So their defense is to bite you. I've seen videos online of loggerheads spinning around and biting the gills of bull sharks. So when they get scared, they get defensive, they're going to turn around and try to bite you. So we make sure that we hold them by their shell where they can't get a hold of us. We're very careful on the boat with our feet and our toes when we're working with them. Loggerheads, green turtles, they max out around 350, 400 pounds. Maybe probably a green turtle. There's probably one out there that weighs 450, 500. You know, historically.
You have to get them on your boat.
Have to get them on a boat. Yeah, that's fun. Yeah, the boat has a cutout in the side of it, so it's closer to the water level. So in the big green turtles, the ones that weigh 300, 400 pounds, we send 2 guys into the water. So there's 2 people pushing and 2 people pulling, and a little bit of leverage, and we can get them in. We got a couple big guys on the boat, and it works out. But yeah, they are heavy, and then yeah, again, you have a 300-pound animal that's trying to bite you. Like I've always said, I'm really glad they can't run. If they could run, we'd have major problems. But they just kind of crawl along. But yeah, we're always extremely careful. So one of the places in the Keys that we look is this area off of Key West. So if you're ever out there in Mallory Square watching the sunset and you look at the islands way out in the distance there, and just past those there is, it's called Mooney Harbor. This is in Marquesas Keys or Cay. And there's this harbor of shallow water, and then there are seagrass beds out here they call the eastern quicksands, high currents, but just deeper, like maybe 12 feet deep seagrass beds. And we find that the larger turtles, so this is the shell length and the number of turtles we catch, the larger turtles, green turtles, are all found there, whereas all the smaller turtles are found inside the shallower waters. So we think that there may be a difference in how they're using habitats, primarily because of predators. The bigger sharks can't get into these shallow waters. The green turtles that size can outmaneuver them. The big green turtles just don't care. They're faster, they're more agile than the sharks, and it's worth them. They need more food to go out in those deeper waters. And these are some of the big green turtles here. Yeah, there's some chunky, fat green turtles. And again, everybody gets very excited to take pictures with these guys because you just worked really hard to catch this turtle. And so this is the Marquesas again. These are all the locations of all the turtles that we have cited. We're working with the National Marine Sanctuary there to actually make the yellow box a research-only area, so there'd be no fishing inside of that area. No other use would be allowed in there except for researchers. So it would actually preserve this habitat for sea turtles and prevent them from getting caught and hopefully in crab traps and run over by boats and that sort of thing. So some conservation coming out of this study. Another thing, we have hawksbills down there. This is a species that we don't normally see around here too often. They're typically more in the Caribbean, but we do see them in the Keys. This is Mercasis. Again, it's kind of hard to see because this is a habitat map, but they're spaced throughout. Key West is right here, and all those little islands, we find them in some of the different habitats there. But the cool thing about them is when we take samples of for their genetics, they're not Florida turtles. We don't have a Florida nesting population of turtles. Most of them were born on beaches in Mexico. Some are Cuba, Barbados, Antigua, Brazil, Puerto Rico. So basically, the Yucatan, I mean, all over the Caribbean, these turtles are migrating and ending up in the Keys. So it really shows the importance of international conservation. You know, we can protect the turtles here, but we need to make sure that their nesting beaches are protected throughout the Caribbean and vice versa. We see that with all of our species. Sea turtles, you know, don't recognize barriers for countries and borders. They kind of go all over the place. So we have to look at that from more of an international standpoint. One of the other projects, this is Big Bend. This is new, this is exciting for us. So the Big Bend area of Florida is interesting because there's no sandy beaches. Most sea turtle work has been done in areas where there's sandy beaches because the turtle biologists are already there, look at the nesting beaches, and they go over and look at the water and say, oh, there's turtles. And they start checking them out there. Here, there hasn't been that emphasis, but there's 200 miles of Florida coastline. Again, there's no nesting sea turtle habitat, no sandy beaches, but there's these extensive seagrass beds. And we know seagrass beds are important developmental habitat for sea turtles. And the area also provides the nursery grounds for fish and invertebrates, commercial shellfish fishery there. Seagrass beds are like thick, like carpet thick. And there's all kinds of animals out there. This is a loggerhead turtle, dolphin. This is a nurse shark, but we've seen tigers and bull sharks out there as well. This is a little Kemp's Ridley sea turtle. And what we're finding out there is we see a few loggerheads, we see a lot of greens, and we see a lot of Kemp's Ridleys. Now, Kemp's Ridleys are exciting for us because they're the most endangered sea turtle species. They only nest in a couple beaches, one in Mexico, one in South Padre Island, Texas. They're primarily found in the Gulf and the North Atlantic. And because they're only on a few beaches, and there's not that many of them just to begin with, they are the rarest sea turtle. However, we find a lot of them here. They're using this habitat, and the reason we end up seeing probably 4 or 5 green turtles for every Kemp's Ridley, but the green turtles are much more agile and much more nimble when you're chasing them, so we don't get to catch every one. We probably catch 20% of our green turtles, whereas we've caught every one of the Kemp's Ridleys we've ever seen. The Kemp's are kind of slow, they're relatively small, and in the water, this white ring around the edge of their shell kind of sticks out like a sore thumb over the dark green seagrass. So it's a beacon, and you can kind of see it from a ways off. So they're kind of exciting to capture. And again, it's a new species for us. We don't see a lot of them around here. So we're interested in what they're doing there. But the interesting thing we're seeing is, at least in the green turtles, the rate of that FIBROPAPILLOMA disease is at like 72%. It's dropped a little bit since we did this presentation, but it's still up near the 70s. Here in the Indian River Lagoon, this is also Indian River Lagoon at Lake Worth Lagoon. It's somewhere between 50 and 55% of the green turtles have it. The Keys and St. Joseph Bay to the north and south, it's still around 10 to 20%. But Big Bend, we did not expect to see this in Crystal River because there's these giant lush seagrass beds. There isn't a lot of development, at least near where we're studying the turtles. The Crystal River and the Homosassa and some of the other rivers there run from inland Florida and come out into the Gulf, and maybe that has something to do with it. But it was definitely a surprise for us, and we're still, again, investigating why that is so high in an area. We talked about the difference in water quality in the flushing that we see on the ocean side. We don't see the disease as much because the water is constantly new versus the lagoon where the turnover time is longer. In the Crystal River, the waters are so shallow for such a wide length off of the west coast of Florida that maybe the waters aren't moving as much, and maybe there's less flushing there too. We don't really know. We were part of the Deepwater Horizon oil spill response. And a lot of our work was actually done in the panhandle of Florida, where we did a lot of our original work. Basically, they'd send us out on boats. At that time, it's called the Vessels of Opportunity. Basically, they were paying charter fishermen to take us out to go look for turtles. And all these little red dots here are turtles that we found offshore. So the kind of shaded area is where oil had been seen at some point, and this is where we had picked up turtles. So a lot of the time the oil had already disappeared or moved on by the time we caught the turtles, but we were able to document them there. And then after that, as part of what they call the natural resources damage assessment, basically the whole idea is, okay, so you got oil all over this area, how many sea turtles were in that area, and so then we can estimate what impact the spill had. So our job was to say, okay, there was this much habitat that sea turtles would use, and in that habitat we found X number of turtles, so extrapolate that over this whole area. This is how many turtles we think were affected. Each turtle cost BP, say $50 or $500. Multiply those numbers out, and that's what they have to pay in the settlement. But since that is all kind of wrapped up, we've continued a project here off of Venice, Louisiana. It gets you out as far as you possibly can into the Gulf of Mexico and allows us to continue these studies. So what we do is we hire out a commercial fishing boat, charter boat, and they worked with us again during the oil spill, so they got really good at seeing turtles. During the oil spill, these guys weren't allowed to have a fishing rod on their boat. They're charter captains, and all they do for a living is fish, fish, fish. And they said, okay, we'll run your boat, you can go look for turtles or look for oil, but you can't have a fishing pole on your boat. So they would come out with us, and we would take them out to these sargassum habitat. So if you've ever seen the brown algae seaweed that washes up on the beach, that has a little floating, little bubbles on it that helps it float, that's sargassum. So sea turtles like that habitat. If you want to read more, it's all over here. They like that habitat. They spend a lot of time out in that habitat. And it creates these mats and lines when the currents and the winds all push together. And now these commercial fishermen fish this all the time. This is where you go out to catch mahi and tuna and things like that, because everything out in that blue ocean is attracted to these giant mats of life that have sea turtles and stuff on them. So we take these captains out there, and all of a sudden they'd see them. They'd never looked for turtles. It wasn't part of what they were looking for. They were looking for fish and ripples for jumping tuna, that sort of thing. Once we taught them what a sea turtle looks like, because they're only this big out there, the little floating coconuts, they were so good, they got better than we did at seeing the turtles, and it allowed them to use their competitive edge that they had used for fishing. So finally they got to kind of release that a little bit and chase after something with their big giant boats. So that was a lot of fun. They were a lot of fun to work with. But yeah, you can see they're kind of almost like a coconut floating out there. And basically you just back the boat up and you dip net the turtle and bring it ashore, or bring it on board. So this is actually a little hawksbill, some green turtles, some Kempsridleys, and we're working with another researcher, and her name's Kate Mansfield out of the University of Central Florida, and she's putting little tiny satellite tags on these guys to see where they're going. So you can see one here on a Kempsridley, just tiny little backpacks. Still $5,000, but just, tiny little things. And as what she was doing, she put that satellite tag on the turtle, and she put a similar tag that wasn't nearly as expensive, because it didn't have to be as small, on drift buoys. So these buoys or drifters were designed to just float along with the currents in the ocean. And so she wanted to compare the turtles' movements to the ocean currents to see if the turtles were just passively following the ocean currents and just hanging out in that habitat, or if they were actively going in certain directions or swimming. And she's finding out that they are active out there. They know where they want to be and where they want to go, and how to stay in the habitats that they prefer. And so those are some of our research projects we do, but without doing some sort of educational initiatives, it's kind of pointless, right? If we're not talking to you people about what's going on out there, or we're not educating the future generation of marine biologists and conservationists, learning all this is kind of pointless. So what we've actually started to do is we brought on an education manager in the middle here, this big kid, and she has created some really cool curriculum. We don't have a brick and mortar. We don't have a harbor branch or a Smithsonian aquarium that people can visit, but she's created tools that can go to teachers. So they're STEM, so science, technology, engineering, math based. They meet all the state standards, so teachers want to use them, and they're hands-on and engaging programs that are easy to implement. And above all, we make everything we do free. So there is no cost to the students, no cost to the teachers. All of it's is usually underwritten by grants. And one of the coolest things is this traveling trunk program. So it gives kids an opportunity to do what we do in the field every day. This is myself and a coworker at the power plant measuring a little green turtle. And this is some third graders doing the same exact thing with their rubber turtle. Real barnacles, some fake algae there, but it gives kids an opportunity to really experience what we do. And the cool thing is they're learning things they need to know for their state standards without even realizing they're doing it. Because they're doing math, they're doing engineering, they're using new tools, they're working in groups. Some of it there are written portions too, but they're so excited about doing this project and it's so different that they don't even know that they're learning. That works out really great. It's been really kind of eye-opening to see how excited everybody gets about it. You know, and it was funny, I was here the day this happened. There's kids in the back like talking to each other, and I hear some kid like, "I feel like a real scientist," and I'm like, "Yes, this works." You know, and then it makes me wonder. I'm like, they could have my job, you know, really easily. Yeah, there's some pretty smart kids. But so each of the turtles we have actually have different injuries and are all set up a little bit uniquely. We put dive weights inside of them, so they all weigh different. So the kids have to weigh the turtles and see if they're healthy or not. This one has a fishing hook. The other one has a plastic bag. So that's something we see on a daily basis with turtle injuries. And you know, some of them were tagged, some of them weren't. So the kids get a really kind of an immersive experience in our education programs. And we're really excited we've been able to expand this throughout Florida. Basically Broward County up, we're missing Brevard, but most of Florida's East Coast, and it's over on the West Coast as well. So basically, teachers call us up, they want the trunk, and we give it to them for free for 2 or 3 weeks. They run through the lessons, they can share it with all of their other teacher friends, and they bring it back. And everything is in there for the kids and the teachers. That's the greatest thing. The teachers can pick it up on Sunday and teach it on Monday. So that's kind of one of the things that we've noticed has worked out really well. And if you're interested in anything else we do, check out our website, Inwater, one word, INWATER.org. We do have all our different projects up there. Check us out on Facebook, Inwater Research, same on Instagram. We post a lot of new pictures about what's going on or exciting things we see. Thank you guys all for coming this morning. I appreciate it.